In this video, we're going to discuss the reduction of carboxylic acid derivatives to aldehydes. Previously, what you learned is that you could take a carboxylic acid and reduce it using lithium aluminum hydride and following it up with an aqueous acid workup. You may recall that carboxylic acids are not easily reduced and that lithium aluminum hydride is super reactive. Because of this, it's not going to be able to create an aldehyde, because what you're actually going to see is that you do create an aldehyde, but then it gets further reduced to an alcohol when using lithium aluminum hydride. So if we want to go from carboxylic acid to aldehyde, we need to use something a little less reactive. So this brings us to some new reducing agents. Our first one is lithium triterbutoxy aluminum hydride. The shorthand, which is still not very short, is right here. This is your reagent over here. And just like lithium aluminum hydride and sodium borohydride, this is essentially a source of the hydride anion. Remember, that is hydrogen with a lone pair and a negative charge. This reaction is performed at negative 78 degrees Celsius. This helps to slow down and control the reaction. Our other one is diisobutyl aluminum hydride. This one actually does have a really nice shorthand, which is dival. It is also a source of hydride, as the name probably tells you. So this one is a little bit different. You have your isobutyl groups, which is where the diisobutyl part comes from, and then you have the hydride on the aluminum. And this is done at very similar reaction conditions. Your solvent is hexane, your temperature is negative 78 degrees Celsius, and you follow it up with a water workup. Negative 78 degrees Celsius sounds really random, but remember, this is actually the temperature of an acetone and dry ice cooling bath. So it's not random at all. So let's see what this looks like in use. You can take an acid chloride, which is our top compound here, and react it with lithium triterbutoxy aluminum hydride at negative 78 degrees Celsius and follow it up with water, and you will synthesize an aldehyde that has the same carbon framework as your acid chloride. So essentially you're just displacing the chloride with a hydride. You can react an ester or a nitrile with dival, and it'll give you an aldehyde. So for example, if we take this slightly more complicated ester and react it with dival, try and come up with the aldehyde that would result from this. I'm going to give you a second to pause and try and work this problem out. So remembering that the way that these reagents work is that the hydride attacks the carbonyl and essentially kicks out leaving groups, you have to be able to recognize that this is your leaving group and it's going to unravel and turn into a straight chain, because this is also part of the carbon framework, the R group, right? So what we want to do is just make sure we number our carbons. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Carbon number 1 is going to be an aldehyde, because that is where our carbonyl is currently. And carbon number 6 is going to have an alcohol group coming off of it. So this is the product of this reaction.